This is a RadioShack dollar coin, and this is roughly 1,800 of them. I know that it's roughly 1,800 of them because each one weighs about 5 grams, and I have around 20 pounds of them. To start things off, I have to create a pattern and a sand mold in order to turn these coins into a guitar. I'll be turning them into a Lapsteel guitar, which is a type of guitar I've never built, let alone played, so I was pretty excited to take this project on. You might be wondering, why do I have 1,800 RadioShack dollar coins? I actually got them from a relative of mine who gave them to me about a year ago to see if I could build a guitar out of them. I'm not quite sure why he had 20 pounds of RadioShack coins. RadioShack's been closed down for a number of years now, but I don't know, maybe he was the world's biggest RadioShack fan, or perhaps he was betting on these coins going to the moon, and an argument could be made that they have. There's listings on eBay showing that they sell for anywhere from $3 to $10 a coin, which is a pretty sizable increase on their $1 original value. So I figured I had two options. I could spend the rest of my life selling them on eBay and consequently crashing the market for these coins, or I could melt them down and destroy the inherent value of them in the name of art and music. Got the mold all done. Now it's time to see if I can turn these coins into a guitar. So if you haven't noticed yet, these coins are made of aluminum, and I'm just wrapping them in some aluminum foil, kind of turning them into little coin burritos so they're easier to drop into the crucible. Got all my RadioShack coin burritos ready to go, just waiting on the furnace to heat up. Check this out. I just noticed on the bottom of the coin, it says offer expires July 31st, 1977. And as far as I can tell, they all have the same date. What a cool little collectible piece of 20th century retail. Well, that pour didn't really go as planned, and obviously not the greatest result here, but I have a pretty good idea of what went wrong, so let's try it again. These molds are well over 100 pounds, and they take a good 4 to 5 hours to make, so I was really hoping that I could nail this attempt. The last mold had two main problems. First, my propane tank froze, and so the aluminum never got as hot as I would have liked. Second, my feeder gates were too small and the aluminum didn't flow properly. So I made them about 3 times larger on this one. I went ahead and chopped up the first attempt on the bandsaw so that I could melt it back down. I still had a bit of excess aluminum from the first pour that cooled in the crucible, so I added in the chopped up pieces and I also threw in another coin burrito. I ended up melting all but one coin burrito. So roughly 100 or 200 coins maybe made it out of this project intact. This one's not perfect, but definitely a lot better. It's got some voids in certain areas, an ugly spot here on the bottom of the neck. We'll have to see what we can do there.
But all in all, it looks like it is a usable part.
I went around and chopped off the risers and then began cleaning it up a bit. Then I started working on the top of the guitar, which is basically just going to be a thin, flat piece of aluminum. And I've never tried casting something this thin, so I wasn't really sure how it was going to turn out, but that's kind of the fun part about metal casting. After pulling the top out of the mold, I sprayed it down with some water, which was really cool because the water just instantly vaporizes when it hits the part. Well, that was really stupid because I just warped the top by spraying it with water and cooling it down too fast. So it's going to require some additional work. It would have been best if I had just left the piece in the mold to slowly cool down. Sometimes I just get too anxious to pull something out of a mold and see what I've got, when in reality, patience typically yields the best results. But I was able to take it over to my friend's shop where we hit it with a torch and then gave it a few smacks with some square tubing, and that flattened it back out pretty good. I wanted the top to be recessed into the frame, so I took a grinder and cut off about 3/8 an inch from the frame so that the top could sit flush. And then I cut out the top to shape and ground it flush with the frame and added a bevel to both the frame and the top so that we could weld in a bead to connect the two. And by we, I mean a professional welder. I don't even know how to TIG weld, and my friend's TIG welder isn't powerful enough for this job, so I took it to a local welder here in town to see what he could do with it. Just brought it back from the shop, and now it's got a nice bead connecting the frame and the top. He was also able to fill in most of these voids and ugly spots, so yeah, very happy with how this is coming along. I always try to do as much work as I can within my own shop, but every now and then there's something I need done that I just don't have the equipment or the skill to do. So I never really have a problem seeking out the help of a professional when those times come. At this point, you might be having a difficult time picturing how the shape of this Lapsteel guitar is going to turn out. My vision for this was to leave the fretboard open so that you could see through it, and then span the frets across the frame on top. I thought it would give it kind of a unique style that I haven't really seen before, and it's possible because on a Lapsteel guitar, the frets are just there for visual representation. The strings don't ever actually contact the frets. This is a cheap Lapsteel that I bought online, and I got it because I needed to practice playing Lapsteel for this video. This is a Duesenberg multi-bender bridge, and I ordered this separately from Germany, and then I installed it onto this Lapsteel. I really wanted to get this bridge because it's got a pretty cool feature unlike anything I've ever seen before. The way I have it set up is so that these two arms bend the G and B strings, and you can set them up to bend a half step, full step, whatever you want. At this point in the build, everything has already taken shape for the most part. Just some additional cleanup and sanding, lots and lots of sanding, and some filing on the edges just to round over the sharp corners. I marked the fret placement by hand, and then I used my super high-tech fret slotting jig to cut the fret slots. And then I beveled and sanded the fret ends smooth, made sure everything was nice and tidy, and then I labeled each individual fret and punched them right back out of their slots. And you would never normally do that, but the reason for that is because of my next process, which is anodizing the aluminum. Anodizing is essentially just a process that creates a protective oxide layer on the aluminum. It's done by adding 2 pieces of aluminum to an electrolyte solution, then you run an electrical current through them for a period of time, which can be anywhere from 30 minutes to a few hours. Then you can dye the piece a color if you want, and you finish it off by boiling to seal it. The protective layer is more scratch resistant and doesn't smear. Plus, you can add color to the metal, which is pretty cool. I ran a number of tests anodizing aluminum scrap, and I found that if I agitated the water a bit, the anodized layer comes out much more even. So I added a small water pump to provide the agitation. And then I took some aluminum plate and cut it up to create a cathode for the anodizing process. And then I attached them using some aluminum wire, placed the pump in the tank, and filled it with distilled water. All the water used in this process is distilled. Once the tub was filled with water, I checked the temperature and it was right around 70 degrees. I then began adding in a gallon of sulfuric acid, which is a pretty serious chemical. It's basically concentrated battery acid, so this part of the process is no joke. I added it in slowly over a period of an hour. When mixed with water, it undergoes a chemical reaction which heats up the solution. So by spreading this out over time, I was trying to limit that reaction so that the solution doesn't get super hot. It's also super important that the acid gets added to the water and not the other way around, as this can cause a serious chemical reaction that would be insanely dangerous. Took the Lapsteel and gave it a degreasing and a scrubbing with some dish soap just to remove any of the oils on the part. Mounted the guitar with some titanium wire so that it would be free hanging in the tub, and then I added it to the anodizing tub. Attached the negative connector to my cathode, which are the big pieces of aluminum around the edge of the tub, and then the positive connector to the anode, which is just the guitar. Set my volts and amps along with a timer, and the anodizing process was underway.
Small bubbles forming off the part, which is a good sign.
This was a pretty big jump from the small test piece that I was anodizing, so I kind of just crossed my fingers and hoped it worked out. This is kind of interesting. Not sure how well you can see it, but it looks like the weld marks appear to be re-emerging. I set up a rinse tub with distilled water and then a dye tub with hot water, to which I added my anodizing dye. After 2 hours of anodizing, I pulled the guitar and gave it a rinse, and you can see that it's now a much darker shade of gray. So this is a good sign that it did indeed anodize. Plopped it into the dye tub where it sat for 10 to 15 minutes. After about 5 minutes, there was already a pretty good shade of red on it, which was quite a relief to me. This pretty much confirmed that the part did anodize. But then back into the rinse, followed by a swift bang on the steel tub. And there it gets submerged in the boiling water where it'll sit for another 20 minutes to seal.
Alright, so the anodizing process is now complete, and overall I'm pretty satisfied with how it went. There's some funky stuff going on here on the face, where there's kind of these specks and marks of areas that didn't appear to anodize, and my guess is that these are just the imperfections from casting that emerged during the anodizing process, but it kind of gives a patinaed feel to it. And then, like I mentioned earlier, the weld marks also re-emerged after anodizing, which is pretty interesting, and my guess is that it's because they're a different alloy of aluminum, so they probably have different anodizing characteristics than the rest of the part. And finally, there was one area here on the underside that didn't appear to anodize, and my guess for that is that it probably didn't have a direct line of sight to the cathode. But yeah, pretty stoked this worked out.
I drilled out little fret markers along the neck where I'd eventually insert some small screws just to act as fret markers, and then I gave the thing a polish and just went along reinstalling everything and getting it wired up to play. As always, I'll have a demo coming up after the final reveal. I probably practiced for about 40 or so hours on that cheap Lapsteel before filming the demo for this one. It really is kind of like learning an entirely new instrument, but luckily for me, I do enjoy that process. I've posted a separate video detailing my final thoughts on the guitar, which I uploaded to my second channel. The link to that will be in the description if you just want to hear some more of my technical takes and logic behind the build. And last but not least, I've got a few guitars posted for sale on my website. The link to that will also be in the description. Thank you for watching, and I hope to check back in a few months to see what I build next.